Hello everyone. This video is regarding short circuit parameters, short circuit admittance parameters or Y parameters. Admittance parameters or Y parameters. In a two-port network, the two-port currents I1 and I2 are expressed in terms of V1 and V2. The equations will be like this. If we write the equations in matrix form, we will get the equation like this, which is simply as I is equal to Y into V. Here the parameters Y11, Y12, Y21 and Y22 are known as admittance parameters. Let's check each one. The first one is Y11. From the first equation itself, we can write Y11 is equal to I1 by V1 provided V2 is 0. V2 equal to 0 means the output port is short circuited. So Y1 is the driving point admittance with the output port short circuited. It is also called short circuit input admittance. Now the second term Y21. From this equation it is clear that Y21 is equal to I2 by V1 when V2 is 0. Y21 is the transfer admittance with the output port short circuited. It is also called short circuit forward transfer admittance. Now the next term Y12. From here we can write Y12 is equal to I1 by V2 when V1 is 0. V1 0 means input port is short circuited. Y12 is the transfer admittance with the input port short circuited. It is also called short circuit reverse transfer admittance. Then the next term Y22. Y22 is I2 by V2 when V1 is 0. Y22 is the short circuit driving point admittance with the input port short circuited. It is also called the short circuit output admittance. Next, equivalent circuit of the two-port network in terms of Y parameters will be like this. The currents are I1 and I2. Now, from this side, it is clear that I1 is equal to current through this branch plus Y12 into V2. Current through this branch will be equal to V1 into Y11. So we will get the equation as I1 is equal to Y11 into V1 plus Y12 into V2. This is our first equation. And if we consider this side, here I2 will split into 2 and we can write I2 is equal to current through this branch plus Y21 into V1, this current. So we will get the equation as I2 is equal to Y21 into V1 plus Y22 into V2, which is exactly same as this equation. Now, condition for reciprocity. Let's consider the first case where excitation is given to the first port and response is measured from the second port. Here, excitation to response ratio is Vs divided by I2 dash. Now we have to find out this ratio. And from this diagram, the first port voltage V1 is equal to Vs. And the voltage at second port V2 is clear that from the diagram it is clear that V2 is 0. And the current I2 is equal to minus I2 dash. Now let's consider the Y parameter equation. I2 is equal to Y21 V1 plus Y22 V2. Now substitute the values. I2 is minus I2 dash. Y21 into V1 is Vs plus this is 0. So we got Vs by I2 dash excitation to response ratio Y21. Now let's move to the second case where excitation and response are interchanged. From the diagram, it is clear that V1 is 0 and V2 is Vs and I1 is minus I1 dash. Here, excitation is Vs and response is I1 dash. So, excitation to response ratio Vs by I1 dash, that we have to find out. Now, from the y parameter equation, I1 equal to y11 into I1 plus y12 into I2. Substitute the values. I1 is minus I1 dash equal to, this is V1, this is V2. Y11 into 0 plus y12 into Vs. So Vs by I1 dash is y12. In the first case, excitation to response ratio is y12. In the second case, excitation to response ratio is y12. And for this circuit to be reciprocal, excitation to response ratio in both the cases should be same. That means V2 by Vs by I2 dash should be equal to Vs by I1 dash. Then only we can say that the circuit is reciprocal. And Vs by I2 dash is y21 and we got Vs by I1 dash as y12. So the network will be reciprocal only if y21 and y12 are same. Now, condition for symmetry. Condition for symmetry is that input port voltage to current ratio when V2 is 0 should be equal to output port voltage to current ratio when V1 is 0. When V2 is 0, we know the parameter equation I1 is equal to y11 into V1 plus y12 into V2. When V2 is 0, this will be I1 equal to y11 into V1. So, V1 by I1 is y11. Only when V2 is 0. So, we got it as y11. This should be equal to, consider the second case when V1 is 0. Let's consider the equation I2 equal to y21 V1 plus y22 V2. When V1 is 0, this term will be 0. So I2 equal to y22 into V2. Then we will get V2 by I2 equal to y22 when V1 is 0. So this is y22. So this is the condition for reciprocity. For the network to be reciprocal, y11 should be equal to y22. Now let's move to another problem. This is the question. Find the y parameter of the network shown in figure. First of all, let's mark the, let's approach the circuit using nodal analysis. So I am considering this node as the reference node. Then potential at this node will be V1. Potential at this node will be V2. I'm considering a third node at potential V3. Now from this circuit, we can write I1 as V1 minus V3 by 1. Or I1 is equal to V1 minus V3. Let's consider it as equation number 1. Now let's write the expression for I2. I2 will be equal to this potential minus this potential by 3. That means V2 minus V3 by 3. This is equation number 2. Now let's apply KCL to node 3. Sum of incoming current is equal to sum of outgoing current. This will be V3 minus 0 by 2. Substitute the values for I1 and I2. I1 is V1 minus V3 plus I2 is V2 by 3 minus V3 by 3 equal to V3 by 2. That is V1 plus V2 by 3 is equal to 11 by 6 V3. Or V3 is 6 by 11 V1 plus 2 by 11 V2. Let's consider this as equation number 4. This is equation number 3. Now substitute 4 in 1. Value of V3 is substituted in equation number 1. Then we will get I1 is equal to V1 minus 6 by 11 V1 minus 2 by 11 V2. That is, separate the terms. I1 is equal to 5 by 11 V1 minus 2 by 11 V2. Mark it as equation A. Then the next step is to substitute 4 in equation 2. Substitute the value of V3 in this equation. Then we will get I2 is equal to V2 by 3 minus 1 by 3 into 6 by 11 V1 plus 2 by 11 V2. Simplifying and separate the coefficient. Finally, we will get I2 is equal to minus 2 by 11 V1 minus 3 by 11 V2. This is equation number B. Now compare the equations A and B with Y parameter equations. The Y parameter equations are, we all know I1 is equal to Y11 into V1 plus Y12 into V2, and I2 is Y21 V1 plus Y22 V2. These are the Y parameter equations. Compare the equations A and B which we got with these two equations. Then we will get the values for Y11, Y12, Y21 and Y22. Their values will be 5 by 11 minus 2 by 11 minus 2 by 11 minus 3 by 11. Now let's move to another problem with dependent source. Here the circuit is having a dependent current source, a voltage dependent current source. Here also let's use the same approach. Here potential is V1 compared to the reference. Here it is V2. So we can write I1 is equal to V1 minus V3 by 2. Equation 1. And I2 as V2 minus V3 by 2. Equation number 2. Then KCL at node 3. Incoming currents are I1, I2, one more incoming current from this branch, which is 3V2 equal to 0. This is equation number 3. Now substitute the values for I1 and I2 from equations 1 and 2. It will be V1 minus V3 by 2 plus V2 minus V3 by 2 plus 3V2 equals 0. From here, we will get the value for V3 as 1 by 2 V1 plus 7 by 2 V2. Equation number 4. Now we got the value for V3. Now substitute value of this V3 in equation 1 and equation 2. So substituting equation 4 in 1. Then we will get 1 will change to I1 is equal to V1 by 2 minus 1 by 2 into V1 by 2 plus 7V2 by 2. Finally, we will get it as 1 by 4 V1 minus 7 by 4 V2. We got I1 in terms of V1 and V2. This is our equation A. Now, substitute the value of V3 in the second equation. That means 4 in equation number 2. Then we will get I2 is equal to V2 by 2 minus 1 by 2 into V3. Half V1 plus 7 by 2 V2. Then finally we will get I2 equals minus 1 by 4 V1 minus 5 by 4 V2. This is our equation B. Next step is compare equations A and B with the y parameter equation. Then we will get the values for y11, y12, y21 and y22 like this, equals 1 by 4 minus 7 by 4, then minus 1 by 4 and minus 5 by 4. These are the y parameters. Then next problem, determine the short circuit admittance parameter for the given network. So consider this as a homework and complete it. Here it is 1 farad capacitor. So the transform impedance is 1 by Cs. So 1 by 1 into S, 1 by S. Here also it will be 1 by S. Then using mesh analysis itself, nodal analysis itself, this consider this one as reference. Here the potential will be V2 itself. Here the potential is V1. Consider here the potential as V3. Then write the equations for I1, I2. Then apply KCL to the third node. And the same procedure solve completely solve the problem. Do it as a homework. The final answer will be S plus 1 by S plus 2 minus 1 by S plus 2 minus 1 by S plus 2 S square plus 3S plus 1 by S plus 2. Complete solution is given in the PDF given. Okay, so thank you all.